Unit 3 Revision Goal, question 18. Now question 18 is a collision question. It talks about a particle begins at negative 3j and moves with a constant velocity of 3i plus 2j. At the same time, a second particle begins from position negative 4i plus j with a velocity of 2ti plus j. Find the position of each particle at time t. Show that the time and position of the collision justify the results of your result. So I've just mapped some of this question start out. We know initially particle A begins at negative 3j and B negative 4i 2j. And then I just put in the velocities, tagging them as A and B. If I want to go to displacement, I'm going to have to integrate, aren't I? So it's going to be 3ti, 2ti plus c. So I need to find c. And that's when I know that RA0, that's going to give me 0i, 0j plus c. But I know that RA0 is negative 3j, so that's my c. So RAT is 3ti plus 2tj plus negative 3j. So it's 3ti, 2t minus 3j is the position vector of particle A. I just had to integrate and find my c. Over here on particle B, the same thing. I'm going to integrate to give me RB. So that's going to be t squared I plus tj plus c. Oops, sorry about that. Now I'm going to have to find c. RB0, that's going to be 0i plus 0j plus c. RB0 I know is negative 4i plus j, so that's my c. So RBT is t squared I plus tj plus negative 4i plus j. So RBT is t squared minus 4i plus t plus 1j. So we now have the position vectors for both A and B. For a collision, RAT has to equal RBT. Oops. Okay, they've got to equal. So 3ti plus 2t minus 3j has to equal t squared minus 4i plus t plus 1j. So I'm going to now equate. I'm going to equate the i's. That means 3t equals t squared minus 4. And if I equate the j's, I get 2t minus 3 equals t plus 1. I'm looking to find the time when they collide. If I solve this, 2t minus t equals 1 plus 3, t equals 4. If that was the easiest one for me to solve, if I've gone over here, I want to get t squared minus 3t minus 4 equals 0. Factorising that, t minus 4, t plus 1 equals 0. I'd get t equals 4 or t equals negative 1. This one's not possible though, because you can't have a negative time. In a situation like that, I generally choose the non-quadratic, the linear one, because it's easier. So then, where do they collide? I'm going to go RBT, or RA, so that's going to be 3 times 4i plus 2 times 4 minus 3j. Just subbing it straight into my R gives me that plus 5j. So now I have, they collide at 4 seconds. Where is then? If I want to justify RBT sub it into the other one. That's going to be 4 squared minus 4i plus 4 plus 1j. Gives me still 12i plus 5j. So justify that position of where they collide is true.